Hello everyone, I am Bouacha, doctoral student at Faculty of Science and Techniques of Mohammedia of Morocco. I'm here to present to you our thesis subject entitled Business IT Alignment in Cloud Computing Uses Process Mining and LLMs Tools. During this presentation, we will follow this outline. So we will start by introducing subject of this work. Then we will go through the background of concepts related to this research area. Afterwards, we will present general idea of some related works. Later, we will quickly explore our comparative study. After that, we will introduce the proposed framework and specify its components, then discuss scenarios we aim to study for using process mining and LLMs tools in our approach. At the end, we will conclude this work and describe our main goals. Let's go to the introduction. So since the end of the 15th century, the considerable evolution of information and communication technologies and their integration of the management of companies have allowed the digitalization of business processes, giving birth to business process management, BPM. BPM has become a success key for organizations in various fields such as industry, services, administrations, by allowing the continuous and progressive improvements of their global performance and processes by ensuring the automation of the later draft IT approaches. At the same time, seeking to avoid or minimize the upfront costs of their IT infrastructure and resources, companies are starting to adopt a service virtualization strategy via cloud computing. This concept has emerged and evolved from its initial IT-centric service models, EAS, PaaS, and SaaS, to more refined multidimensional service models that encompass, among other things, the storage and network dimension and are becoming an important driver of business models and innovation. So reducing costs and increasing flexibility are the initial factors that have driven the outsourcing of all or parts of business processes. But to support non-IT customers with a business-oriented view and this supports existing processes, new innovative cloud service models are also needed while choosing relevant solutions that can grow and shrink with the size of the company. Hence the idea of business process as a service, BPaaS, which today describes business process management in the cloud context, where conceptual models and the semantics are applied to align business processes to workflows deployed in the multi-cloud. Let's go to the background and foundation. So let's explore. So before seeing the existing, explaining first some basic concepts that will allow us to better understand the problem. We have business process as a set of interrelated or interacting activities that contribute to the business goals of an organization. We have also BPMN, Business Process Model and Notation, that is considered as a standard modeling language of business process. It structures and represents the activities of an organization. We have process mining that represents second derivation of data mining and focuses on log-based business processes that links information system domains to business process management. We define three types of process mining models. We have discovery, conformance, and enhancements. And then we have large language models, LLMs, that are the advanced artificial intelligence systems trained on massive amounts of text data to understand, generate, and manipulate human language. So they learn patterns, meaning, and context in language, enabling them to perform tasks such as answering questions, summarizing text, translating languages, and producing coherent human-like responses. As said before, Business Process as a Service (BPaaS) introduces a cloud-based service model for business process. It's a new cloud service type that provides configurable and executable business processes to customers over the internet. It joins the other three fundamental cloud services, SaaS, PaaS, and IaaS, and generally, BPaaS is defined as workflows that are considered the orchestrations of IT services in the cloud. And then we have business IT alignment that aims to use IT in the most efficient way possible to achieve business objectives and improve financial performance or market competitiveness. It's a concept that existed before cloud computing and includes mapping business processes to workflows that orchestrate the services to select and allocate. In a cloud environment, BPaaS implementations requires flexibility for many steps in business IT alignment. So, business IT alignment to transform a domain-specific business process into a cloud-compatible business process is applied in 5 levels of transformation. Level 1, business process. Level 2, technical workflows. Level 3, executable workflows. Level 4, deployed workflows. Level 5, instance workflows, which each level depends on the one before it. So let's go to explore some existing works related to business IT alignment and that propose different approaches. So in a classical framework and traditional cloudless approach, research in the field of process-aware information system has brought to light the need to align business process in the application layer in order to manage the traceability of business needs expressed at the business layer and their realization in the form of a service in the application layer. By establishing rules of correspondence that allow to map the different business models, such as BPMN as a source modeling language, and the elements of the target model, such as UML or SOML in the case of web service. In a cloud environment, the most common architecture for establishing business IT alignment or alignment of the BPaaS layer with the lower layers of cloud services, IaaS, PaaS, or SaaS, is the cloud socket architecture. So the cloud socket platform consists of 4 architectural blocks. First, design, allocation, execution, and evaluation. These components are organized into environments that address specific tasks and research questions. It represents the 4 main building blocks based on the 5 steps of the business process management system paradigm when applied to business process management in the cloud: design, modeling, execution, monitoring, and optimizing. Once the business processes and the respective workflows are defined in the design environment, the allocation and the execution environments are responsible for deploying, provisioning, executing, and monitoring the workflows in the cloud. The execution environment maps abstract workflows to deployable and executable solutions by receiving semantically enriched models from the design environments using BPMN for business processes and DMN for decision management models. Next, the evaluation environment consists of linking monitoring and log information to business KPI and provides other types of BPaaS analysis. And then to browse, to search or select BPaaS offerings, BPaaS customers have a dedicated marketplace. Let's go to our comparative study. We have tried to do a comparative study based on the existing works in this topic. So the works are evaluated according to a set of criteria such as BPaaS environment, alignment approach, type of mining process mining, type of mapping, modeling language, and tools. We have grouped all the results obtained for each criteria in a single table that we had included to a previous published paper. So to summarize, the study carried out was very beneficial and enriching in the way that we were able to extract several elements in common between the approaches and this make a global criticism of the existing and find the limitations on which we can work to improve them. It guided us to deduce that the use of process mining methods is almost absent, especially in the first three cloud socket environments. Second, the most used languages which can be found in the all approaches read are BPMN, DMN, CAML and their extensions. And also, almost or all approaches and methods used remain informal and lack automation. So we aim to propose a more complete approach and address the missing needs observed using process mining techniques in a formal framework. So, as said before, when looking for existing studies on business IT alignment in the cloud environment, we find that most, if not all, works that deal with this topic are generally based on the cloud socket architecture as a standard projecting all the phases of the BPMS paradigm, as well as the different levels of the BPaaS process on the cloud architecture environment. On our side, we also intend to work on the same architecture, but add other tools and innovating technological aspects such as process mining, the use of event logs, and intelligence artificial tools, as well as the formalization of the mapping approach using the MDA model-driven architecture method to improve the alignment process and make it more innovative. We based our approach on a comparative and critical study of existing works where we found a lack of automation and formalization between the different phases and environments of the architecture, especially the mapping rules. Therefore, our principal goal will be to work on these existing approaches limitations to give a result that responds more effectively to the need for business IT alignments in the cloud. Initially, we will focus our works on the first part of the architecture, which is the passage from the design environment to the allocation environment, having as prerequisites the BPMN model or DMN as an initial business model. The KPI is necessary for the allocation of resources in the cloud environment and also the event log to be enriched for use via the process mining, discovery or conformance in order to allocate and choose the right resources to meet the business needs in the cloud. Our study is still in its early stages. We are still in the progress of validating the proposed frameworks and working methods by further depending on our research and reading, especially in the areas that will serve us. We believe that utilizing process mining, especially by leveraging event logs retrieved from previous user experiences or other systems employing similar business process modeling using the same BPMN model, will be highly advantageous for resource allocation in the cloud computing environment. In a cloud environment, selecting the right resources directly impacts productivity and the efficiency of meeting business needs. Hence, our ultimate goal is to automate resource allocation efficiently, accurately, and in line with the various cloud resource allocation metrics. This objective has driven us to consider adopting process mining. Nevertheless, we face several questions regarding our contributions. First, what type of process mining should we use and for what objectives? How can we effectively exploit the event logs? And what are the metrics and criteria for cloud resource allocation that we must adhere to? Are there existing algorithms that address this subject in cloud context? And how can we evaluate the resource allocation effectiveness after execution in the cloud? And more questions that we can address in the next studies. So the objective of the first scenario is to tackle the process modeling aspect of resource allocation in the cloud. In other words, it involves discovering the cloud resources to allocate based on an event log in the BPMN model that lacks resources. To accomplish this, we will employ process mining using the discovery type on the event log retrieved from based or for the past user experience. The second scenario, which also appears important to us and deserves a contributions, aims to automate and optimize the execution of the resource allocation mechanism in the cloud. This time, we target the enhancement aspect of process mining to monitor the existing allocation plan, theoretical resource allocation model, and attempt to improve it by adapting to change. So we have as input the theoretical model plus event logs, and with the process mining enhancements, we aim to retrieve an improved VPMN model with resources allocated in the cloud. And so, if we combine the two scenarios, what will be the results? Can we contribute to both aspects? So, recommending or discovering an enriched theoretical model with the allocated resources based on the event logs, using the discovery parts of process mining, and then evaluating, optimizing, and validating the enriched model with the use of the enhancement parts of process mining to approve the resource allocation made in the cloud. What about the use of LLMs tools? Recent advancements in artificial intelligence, particularly in the development of large language models, LLMs, such as OpenAI's GPT family or Google's Gemini, for example, have opened new opportunities for enhancing automation, decision support, and semantic understanding in cloud-based business process management environments. So integrating LLM capabilities in the proposed BPaaS-based business IT alignment framework can significantly improve adaptability, intelligence, and process optimization at multiple architectural levels. So adding large language models to our cloud socket-based business IT alignment framework can bring a transformative layer of intelligence across all phases: design, allocation, execution, and evaluation, by enabling understanding, reasoning, and automation capabilities that go beyond classical AI. So, integrating an LLM into our framework transforms it from a procedural alignment model into an intelligent, self-learning alignment ecosystem. It allows business experts to interact with the system naturally, accelerates process to service mapping, enhance adaptability in cloud environments, and makes the entire life cycle from design to allocation to evaluation more automated, transparent, and explainable. So, to conclude, we have presented an overview of the business IT alignment problem in the cloud, explaining some basic notions useful for the research topic in discussing the different main approaches that have evoked this problem before to be able to extract their limits. Then we had proposed our framework that will answer the problem using formal approaches, process mining, uh, semantic process tools, and LLMs tools. We had also discussed several scenarios on the use of process mining. This later provides a data-driven, objective approach to understanding business processes in an organization, making it a valuable tool for process improvement, compliance monitoring, and better decision making. In addition, we are concretely looking at how LLMs can enhance our architecture with practical future examples, technical contributions, and benefits by enabling understanding, reasoning, and automation capabilities that go beyond classical AI. Our approach explained, even in our previous publications, initially aimed to automate, formalize, and use the latest of and the most innovative technologies to solve the problem of business IT alignment in a cloud environment. So the next step is to start contributing concretely to the subject by building the necessary algorithm and accurate models applied to a concrete dataset. Here are our references. And thank you for your attention.